of 3D printing news unpeeled. And today we're going to go into a couple of little news items for you. And the first one is from Phase3D. Phase3D has been awarded a 1.25 million US dollar contract, uh, stretching over 2 years, along with a company called VRC Metals, by the Air Force Research Lab. And the AFRL is, by the way, hats off to them because they're becoming quickly one of the biggest funding bodies in 3D printing. It's crazy how a sustained effort by the Air Force Research Lab can bring about so much funding and so many projects ranging from swarm robotics to which is a quality inspection robotic thing, to large powder fusion systems, to large DED systems. These guys are really, really playing a huge role in our industry. So Phase3D already has kind of in situ monitoring gear and software. Basically, you can see in front of you that you attach a bunch of cameras to a printer. I think the one in front of you is M290 or something like this. And you then extract the data and analyze it with their software. They use structured light scanners. And they're doing this already for binder jet and for powder fusion. Now they're going to look at doing this for cold spray. Now, cold spray is something it's kind of niche. Not a lot of people talk about it, not a lot of people discuss it, but it is a great technology for repairing things, for cladding things, for making multi-layers of things. So imagine you wanted a metal composite with all sorts of exotic kind of properties, maybe some copper with some other metal for, I don't know, like an artillery shell, or some other kind of like really heat-resistant materials where you have a duplex kind of material. Or if you want to repair something like a barrel or a blisk, it's a wonderful technology and relatively inexpensive and relatively able to do very highly productive, very, very large scale things. So the rest of the additive industries, cold spray is not a very loved technology because they actually deal directly with customers in like oil and gas and stuff. When they talk to them, they don't spend a lot of time selling us their machines because they know not a lot of people can buy a cold spray machine essentially, but the people that do buy them use them very, very intensively. So it's a different kind of market. So they don't have the giant stands. They don't do the big interviews. They don't do a lot of outreach to our industry. But there is a lot of stuff going on with cold spray, or more than we think at least. So this is a good move. The idea is that this is going to take place at Ellsworth Air Force Base, and it's real-time management for cladding and repair. And basically, they're trying to close the loop essentially. Especially for large-scale manufacturing with cold spray. This can also mean that this solutions will become more inexpensive for molds, mold tooling, oil, gas, cutting tools, stuff like this. Think about every cutting tool in the world. Every single cutting tool in the world could use a cold spray or similar technology to get like a carbide or some kind of 3D printed optimal shape on top of it to perform better. And let's say that cutting tool wears down, whether it's a knife or whether it's a scalpel or whether it's a giant digger or some kind of giant rock crusher thing. Any kind of cool tool like that could have an optimal shape with 3D printing. And once it repairs, you don't have to replace the whole thing. You just print on top of it. Think of just how much fewer energy you would use. Just think about how much cheaper that would be. And that has nothing to do with the fact that Sandvik, of course, is one of the biggest cutting tool companies in the world, is also big in 3D printing. But generally, there could be a link there, and there could be that Sandvik has figured this out already. But yeah, essentially, the only way to really do this cladding thing really, really well is DED kind of processes. And then cold spray could be a really great alternative for the Air Force and other people to have. So I think this is a good development for all of us. It could really lead to more industrial applications outside. We are going to continue talking about cameras because I just know that in situ monitoring and cameras is really what is going to be a big YouTube breakthrough. So university researchers at Carnegie Mellon have come up with a single camera method, which uses a color camera to measure kind of the melt pool. Now, we all know that the melt pool in powder fusion, we really don't know what's happening, to be honest. There's this keyholing effects. There's all sorts of agglomerations. There's plumes of smoke. It's essentially just a giant black box. And that's not a good kind of situation if we want to start making aircraft and stuff like this. So what we want to do is always measure the melt pool. And at the moment, we're using infrared cameras, which seems like a great idea, right? Now, as Carnegie Mellon universities, CMU University researchers have really trying to come up with a new way that really kind of could improve upon what everybody else is doing. And I think this is wonderful for two reasons. One, it might work. And two, if you're trying to monitor melt pool, nearly everyone will go like, oh, we should use a thermal camera. Of course. but what if you could just use another, like a color type camera? Now, this, of course, is with laser powder fusion rather than cold spray, but I'm pretty sure these Phase3D guys are interested in this as well. The idea is that you can take a regular color camera. This one's a really high FPS kind of camera, and look at all the physics in the melt pool during printing, right? So this is not only like an in situ monitoring thing, but we can also do it, throughout the build. We can connect it to software, read out stuff, sort of similar to what these other guys are doing as well. The idea is that it's better than thermal imaging, and it's faster, and it can give you these the data faster, analyze actually more information. So what it does is it can give us a deeper look at this keyholing effects, distortion across the bed, and all this, and at a much higher frame rate and a much higher resolution. So the idea is that when you see this voxel change temperature, you can capture that much quicker and a much more detailed level at a much smaller kind of level of voxel. So this could actually give you much more detailed information than a standard infrared camera. And I just love this, and I think this is really wonderful. And they used commercial color camera with filters on top of it, and they looked at the ratios of the colors and in between each other, and then use that to measure the thing. I think this is like just the super ingenious. You can read the paper. I don't know if it's open access, but I was able to read the whole paper, so you can look at it. And the paper is called High Resolution Melt Pool Thermal Imaging for metal additive manufacturing using the two color method with a color camera. This is by Alexander Myers, Guadalupe Quirarte, and a bunch of other people, and I think it's wonderful. And if you look a little bit more at this, I hope you can see the way they've done this is very much like the other guys have done. They've done this Foxtrol Mini camera, AX200 camera, and they basically put it on top of and looking into, in this case, our the Trump system that they have to test this on. And I think this is wonderful. I think there's a huge market of this. And I hope that, of course, the money is all in cold spray and these industrial processes, but I really hope that we've seen what LiDAR does for the performance of the Bamboo Labs printers, right? We've seen LiDAR coupled with software tweaking and vibration compensation can do for them. And I just hope that there's more of these solutions or tools that do this in situ monitoring, but also just make process and settings better overall. And I just think I think it's a wonderful development. I think this is stuff we need. We can't just keep making stuff and hope is not a strategy if we want to make aircraft parts. Let's put it that way. Another area where hope is definitely not a strategy is in medical 3D printing, which is, of course, in orthopedics. Has been it took a long time to build up, but it's been a huge success of late, with powder bed fusion E-beam being used to make millions of medical devices in spinal cages, total knee kind of surgeries, and also hips, and now across the body as well in orthopedics. So who makes all these things? Well, we of course know that Stryker and other companies, J&J, have been investing in this. There's also smaller, very specialized, notably very Italian companies that are specialized in making 3D printed medical devices. But also there's outsourced manufacturers. One of them is Paragon. Paragon Medical is a considerable one. You should read their they have a thing on their site where they show all the machines they have. This place is a candy store. It's amazing. It's kind of like that thing Autodesk has, but these guys are actually making a ton of stuff. Anyway, so these guys have just opened a new facility, an additive manufacturing facility. They spent $16 million on it, and they're going to be spending another $19 million over the next 5 years. These guys, by the way, have one of these Quintus hip stations. They're one of the very few people that have one of those, and they have a whole bunch of those GF 3D Systems metal printers. They're a partner of 3D Systems, so this is good news for the 3D Systems metal printing universe. And these guys, I think they have a wonderful place in the market because they're really experienced in the CNC machining, all this other stuff. But you can go to them for end-to-end, just the device engineer. You could say like, hey, I'm a surgeon. I've got a cool idea, and this is what I want to do. Presumably, you'd have to find a bunch of money sooner or later. And they can do the engineering, the development of this device, the testing, and finally the manufacturing. So I think that's in a way that the major companies are kind of outsourcing their innovation to smaller startups and single engineers and stuff like this. Yeah, a company like this, it has a really, really great place in additive manufacturing and making all these new devices. Anyway, so this was the news for today. I hope you found this interesting in some way, shape, or form. And thank you very much